Hello friends, so here is another question on electric field. So the question is that an electron, it falls through a distance of 4 centimeter in a uniform electric field of 3 into 10 to the power 4 Newton per coulomb. And when the direction of the field is reversed, a proton falls through the same distance, that is 4 centimeter, and we have been asked to calculate the time of fall in each case, that is first for electron, then for proton. Okay, and then another thing which has been asked is to comment on why the effect of gravity, it does not come into play, or it is negligible in this case. Okay, so we have been provided with the data, the information. Now we have to translate it to the mathematical equations, diagram, and calculate the result. Okay, so first, it has been given that an electron falls through a distance of 4 centimeter in a uniform electric field. Let's say we draw two parallel lines, okay, and we have electric field, okay, like this. Okay, we have electric field lines. We have already discussed about that. So electron, as it is negatively charged, okay, minus negatively charged, it will always get attracted towards the positive side, okay, the positive side. So here basic equations of mechanics, it will come into play. First, the electric field E is equal to 3 into 10 to the power 4 Newton per coulomb. The charge is this magnitude I am talking about, which is E, which is equal to 1.6 into 10 to the power minus 19 coulomb. Charge I am talking about, only the magnitude. So here we know that electric field is equal to force acting per unit charge. So force is equal to Q into E, okay, Q into E. Force acting on this electron will be the magnitude of the charge, that is E, multiplied with the electric field. So here it will be 1.6 into 10 to the power minus 19 coulomb multiplied with 3 into 10 to the power 4 Newton per coulomb. Okay, this. Then acceleration, we know force equals to mass into acceleration, Newton's second law. Force is equal to mass into acceleration. Here force is this much, QE. So if we want to calculate the acceleration of this electron, it will be the force acting on the electron. Let's write it F subscript E. F subscript E, the force acting on the electron divided by the mass of the electron, which is equal to this one, that is 1.6 into 10 to the power minus 19 into 3 into 10 to the power 4 by mass of the electron, that is 9.1 into 10 to the power minus 31, this much. So if we calculate the acceleration, it will be, let us calculate, it is coming around 5.3 into 10 to the power 15 meter per second square. such a high value, acceleration of the electron, we have been asked to find the time of fall of the electron, the time it takes to cover this distance, this gap of 4 centimeter. Okay, this gap between this is 4 centimeter, this one. So here we'll be using the equation of kinematics. We know S is equal to ut plus half at square, where S is the distance traveled, u is the initial velocity, t is the time taken, a is the acceleration. Here initially the electron was at rest, so the initial velocity of the electron will be 0 second. Acceleration we calculated 5.3 into 10 to the power 15 meter per second square. This term will become 0 because u is 0. So simply time of fall of electron t square will be equal to 2se by ae, okay, where se is the distance traveled by the electron, a is the acceleration of the electron, or simply time of fall of the electron is equal to root over of 2se by ae, 2se by ae, which is equal to, that is equal to this much, 2 into here se, the time, the distance traveled by the electron is equal to 4 centimeters. Okay, it is 4 centimeters. That is equal to 4 into 10 to the power minus 2 meters. So we'll substitute this value here because everything has to be in MKS units. 2 into 4 into 10 to the power minus 2, acceleration is equal to 5.3 into 10 to the power 15 meter per second square, and that is equal to, the result is, if we calculate, it is coming around 3.9 into 10 to the power minus 9 seconds. That is the time of fall of the, for the electron. Okay, that is the first case. This is the first case for electron. Then we have the proton. So here in this case, what happened is that the direction of the field is reversed. So now it is, let's say like this, plus and then we have minus. So now a proton, it falls. Proton means positive of the electronic charge, that is falling because it will get drawn towards the negative side. Same 4 centimeter distance, the distance of fall is same. Here also the initial velocity of the proton is 0 meter per second because initially it was at rest. So here we have to determine the force acting on this proton. It will be simply QE, which is equal to, the magnitude will be the same electronic charge E multiplied with electric field E, that will be equal to 1.6 into 10 to the power minus 19 coulomb into electric field, that is equal to 3 into 10 to the power 4 Newton per coulomb. Then we know force, that is the force acting on the proton. We know force is equal to mass into acceleration. So force acting on the proton will be equal to mass of the proton multiplied with acceleration of the proton. So acceleration of the proton will be equal to Fp by mp, force acting on the proton divided by mass of proton, which is equal to 1.6 into 10 to the power minus 19 into 3 into 10 to the power 4 divided by mp. The mass of proton, we know it is equal to 1.67 into 10 to the power minus 27 kg. So here this value, acceleration of the proton, that is equal to 2.8 into 10 to the power 12 meter per second square. That is the acceleration of the proton. Again, using the basic equation of kinematics, S is equal to ut plus half at square. So Sp here, the distance traveled by the proton, will be up Tp half ap Tp whole square. Up is equal to 0, initial velocity is 0 because it was initially at rest. So this term will become 0 and Tp will simply be 2 Sp by ap root over. Same equation we have used. So it will be root over of 2 into same distance 4 centimeter for proton also, 4 into 10 to the power minus 2 by acceleration, which is equal to 2.8 to 10 to the power 12. So if you calculate, it is coming around 1.69 into 10 to the power minus 7 seconds. Okay, Tp is this much, 1.69 into 10 to the power minus 7 seconds, this much. This is the value. So time of fall for electron is this much, 3.9 into 10 to the power minus 9 seconds. Time of fall for proton is this much, 1.69 into 10 to the power minus 7 seconds. Now another thing which was asked, why the effect of gravity is negligible in such cases. So yeah, see, look at the acceleration of the electron. It is 5.3 into 10 to the power 15 meter per second square. Gravity is 9.8 or 10 meter per second square. It is very large as compared to this. Also for proton, the acceleration is this much, 2.8 into 10 to the power 12 meter per second square. It is very high as compared to g, okay, much greater than g. So that's why the effect of gravity is negligible in these cases. Okay, so here a very good question which combined the concepts of electric field, electric charge, electric field, and also the concepts of mechanics, basically kinematics. Okay, so this is the question and we solved it. Okay.